So we are not gonna add the CQI squared. That's one thing. And we start with Corno model. So what do we have for Corno? Corno says demand curve is actually we don't need that. We want this. WF is minus alpha sigma QI squared WF, right? Firm's welfare minus alpha sigma I QI squared, and WC consumer's utility is minus alpha over 2 sigma I QI squared minus beta sigma I less than j QI QJ, right? Which we computed alpha, and alpha is minus 1/2, which will be 1/2 sigma on I QI squared, which will be 1/4 QI squared beta minus beta, and beta is R, which is negative, minus R sigma I less than j QI QJ. So we want to maximize total welfare, which is welfare of the consumers and the firms. And we can also say actually welfare of the platform included. WT will be 3/4 sigma QI squared minus R I less than j QI QJ, and you want to maximize this expectation. Expected of WT will be which QI is AI, right? Which will be 3/4 Yeah, I just solved the. We are gonna only solve this problem. We are not gonna do it for like its first best or its truthfulness without obedience. No, we just want to solve the optimal welfare. No benchmark for this. So it will be 3 over 4 n sigma ai squared plus 3 over 4 n mu ai squared minus r so how many different we have? N, 2 out of n, right? N minus 1 over 2 n minus 1 over 2 sigma ai aj minus r n minus 1 over 2 mu ai squared. Mu ai and mu ai squared. Mu ai, because obedience gives it away, it's already determined. So we want to maximize, and we can remove one of these ends and one of the 1/2. So maximize finally 3 over 2. Sorry. Okay, one point is that we want to have a linear combination of WF plus WC. So let me clear this stuff. Okay, I'm lucky I just remembered it right away. So let's say WT is WF plus eta WC, and which eta is a positive number, and then WT will be WF 1/2 2 plus eta over 4 sigma qi squared, right? It will be 1/2 and 1/4 eta over 4 plus 1 2 plus eta over 4 qi squared minus r eta I less than j qi qj, right? And then expected of WT will be 2 plus eta over 4 n sigma ai squared plus 2 plus eta over 4 n mu ai squared minus r eta n minus 1 over 2 sigma ai aj minus r eta n minus 1 over 2 mu ai squared. We can get rid of these two terms here, obedience, and we can get rid of n and sum of over 2's. So we want to maximize, actually maximize 1 plus eta over 2 sigma ai squared. Eta is positive too, by the way. It doesn't make sense to keep eta negative. Eta greater than or equal 0. Alright. And 1 plus eta over 2 sigma ai squared. Oh, actually, yeah. Minus r eta n minus 1 sigma ai aj. Subject to, we have our PSD, we have our obedience, we have our IR, truthfulness, and we have our IR, incentive, individual rationality. Let's take a look at our previous optimization problems. By the way, you can see that we don't require anything special on payment. And we care if ICIR binds. So the good thing about optimal welfare is that we don't care much about payment, you know. Payment will be computed. Yeah, that's the objective. And where is optimal welfare? That's the new problem. By the way, R needs to be in somewhere. For Cornell, right? Beta is R and beta is between alpha and minus alpha, right? And minus alpha over n minus 1. Beta is R, which is between minus 1/2 and 1 over 2 n minus 1. Alright. Perfect. So So again, we forget about truthfulness. We forget about IR. We just assume it. We try to solve the optimization problem with our given objective function, PSD, and obedience, and then check if it is truthful. Well, we check if it is actually that's what we want to. We check if we want to check if x, which is sigma ai theta I over t sigma theta I squared is greater than or equal to 1, which individual rationality or truthfulness requires us. Well, only individual rationality. Now I want to go to the structural result. Relief.com. This is also one thing I'm sure we will get back to. So, relief. What is F? So these are our constraints. The first two are PSD and the second two are obedience. F, we explore in this section. When both the prior distribution and the objective function in F are symmetric, that is invariant under relabeling of the planars, then we can restrict, which is the case here as well. 1 plus n eta over 2 sigma a square minus r, yes. Then we can restrict to symmetric mechanisms in 17 without loss of generality. Unsurprisingly, given that our game is symmetric, we show below that both welfare and revenue are symmetric in K. Assume that prior distribution on players. Well, f is concave, which is linear here, right? So we are good to go. And strictly monotone in sigma iij, which is, the term is minus r eta n minus 1, which is r is negative. So round f round sigma aiij will be minus r. We are trying to maximize f. Yeah, supremum, exactly. Minus r eta n minus 1. So eta is positive, n minus 1 is positive, r is negative, so the whole thing will be positive in general. So we are in the first case. Direction recommend maximally positively correlated condition on theta omega, and we can write this for some delta. And then we have the ellipse equation where x and y are there. Center is this. We have mu ai, we have sigma ai theta j. And theta omega. So we have x, we have y, sigma ai theta j. What about sigma ai omega squared? Sigma ai squared will be sigma ai j, sigma ai omega, sigma ai theta. So we have this one and this one. We found a theta j as well. We have ai theta I. Oh, no. ai theta I gives you ai theta j. And then what is left? ai aj. Oh, which one is binding? When r is negative. That's the important case. So the whole coefficient behind sigma aj is positive. Therefore, once we want to maximize the objective, we are bounded, because the second term, the second PSD doesn't give us an upper bound on sigma iij, but the first one is the one who is giving the upper bound on sigma iij. The first one is giving us sigma iij. First PSD is binding, and we have sigma ai aj equals sigma ai squared minus 1 over sigma theta I squared sigma AI theta I minus sigma AI theta J squared. Right? Maximally positively correlated. And let's go over this term here, which I said we needed. First one, in the first inequality, if covariance of AIJ equals variance of AI, so maximally correlated. How do you compute covariance of AIJ? Okay, that's the formula actually. Alright, I have to take a pause. Alright, and okay. For core now R is negative, right? And then this positive maximally positively correlated. Perfect. And I want to add getting distracted. I guess Bertrand is the same problem, just R is... Well, it's not the same problem, we know that. RSD are different. Anyways, for Corno, R is negative. And we want to maximize this term. Let's go take a look at our codes. Here. R is negative here, sigma AI theta J. Dude, I'm getting distracted. Fuck. Let's go ahead. So all of the structural result, put it aside. Let's do max. Also, I want to take a look at the code. For optimal welfare. Is it research? So we have the elliptic inequality based on x and y and r, and we have hyperbolic. These are the from the stationarity KKT condition. All right, and then we have what do we have? That's how we solve it. Let's do the same for, yeah, these hyperbolics have the effect of the new objective function. So it is maximizing. I love this pen. Haven't touched it for so long. 1 plus eta over 2 sigma ai squared minus r eta n minus 1 sigma ai aj. That's subjective. Subject to one over sigma theta bracket here. One plus maximize 1 plus 8 over 2 The thing is that r is negative. We know that it is. Oh no, we have a new objective function. All right. Yeah. Okay. Here, look at this objective function for welfare. Well, interesting. For welfare, we don't round f round sigma ai aj 0 actually. So those two cases are not applicable here. Sigma AIAJ, where is it? Plus S. Fuck you. Plus T sigma theta squared. So we want to get rid of sigma AI squared and sigma AI theta, no, sigma AI theta J. Which ones are the ones you want to get rid of? And then we have sigma AI AJ, sigma AI theta I, and sigma AI omega. Is it the same with optimal revenue? Exactly. So let's get rid of sigma AI squared. We have uh, 1 plus eta over 2 sigma AI squared, which is n minus 1 r sigma AI AJ plus s sigma AI omega plus t sigma AI theta I. Perfect. And minus r eta n minus 1 sigma AIH. That will be the objective function, which turns out to be n minus 1 r sigma AIHJ times 1 plus eta over 2 minus eta will be 1 minus eta over 2, and perfect, right? So it depends on the value of eta. If it is less than 2, if it is bigger than 2, plus 1 plus eta over 2 s sigma AI omega plus T sigma A, the same thing. 1 plus eta over 2 T sigma AI theta I. And then the objective function will be first constraint, first PSD. First PSD says they are maximally correlated, right? Not here. No, 127. Yeah, here. Maximally correlated, which we believe that's the case here. So 1 over sigma theta I squared sigma AI theta I minus sigma AI theta J, which is n minus 1 R. Oh shit. Sigma AI theta J is something we know based on sigma AI theta R. Sigma AI theta J is sigma AI theta I minus T sigma theta I squared. Actually, we should have these constraints for the welfare as well. Constraints won't change. N minus 1 R squared should be less than or equal sigma AI squared, which is n minus 1 R sigma AI AJ plus S sigma AI omega T sigma AI theta I minus 1 sigma AI AJ. And second PSD, first PSD says that, second PSD says 1 over sigma theta I squared sigma AI theta I plus n minus 1 sigma AI theta I minus T sigma theta I squared over n minus 1 R squared plus n over sigma omega squared sigma AI omega squared. There is no S. Yes. Less than sigma AI omega AI squared plus n minus 1. So it will be n minus 1, 1 plus R n minus 1, 1 plus R sigma AIAJ where is it? Sigma AIAJ plus S sigma AI omega plus T sigma AI theta. So if eta is less than 2, this is positive, and again the first PSD is winding. If eta is greater than 2, the objective is increasing in sigma Aj. So if eta is less than 2, the objective is decreasing in sigma Aj. So we want to have decreasing, we want to have a lower bound. The second term gives us the lower bound. If eta is greater than 2, it's increasing in sigma Aj, and the first one gives us the upper bound. So okay, now structural result told us that in only 3 variables. I think a structural result is just based on 3 variables. Okay, then that's good. Symmetric and obedient mechanisms. What is OS? So this is K, alright. That's it. I don't know. Fucking structural result, that's problem. Therefore, then n-1 r sigma ai aj 1 minus eta over 2 plus 1 plus eta over 2 s sigma ai omega plus T sigma AI theta I. So we want to maximize this. Subject to first PSD, which is 1 over sigma theta I squared sigma AI theta I minus, okay, we can simplify this too. N minus 1 R minus 1. This is second PSD. Let's take a look at optimal welfare. Now we are changing to F. It's good. Just checking if we have the same. Well, objective function is different. That's not a problem. So on the first PSD, you're saying r squared sigma theta I squared. They're all dividing by 1 over n minus 1 will be r minus f sigma ai theta I minus ft. That's my problem. Each wants to be r minus f sigma ai theta I. Minus ft sigma theta I. Why f minus r? That should not be real. Let's go over optimal revenue. Okay, let's do the first PSD again. What was that? First PSD. Okay, where is my first PSD? One over sigma theta I squared sigma ai theta I minus sigma ai theta j squared less than sigma ai squared minus sigma ai aj, right? 1 over sigma theta I squared. Sigma ai theta I will be now we need obedience. This is revenue. I want obedience. Okay. Sigma AI theta I. Sigma AI theta J, which is n minus sigma AI theta I minus T sigma theta I squared over n minus 1 R AI theta J, which is sigma AI theta J is sigma AI theta minus T sigma theta n minus this shit squared should be less than sigma AI squared, which is n minus 1 R sigma AIJ minus 1 also plus S sigma AI omega plus T sigma AI theta I. Is it the same thing you have here or no? Perfect. And then we can say sigma theta I squared n minus 1 R minus 1 plus okay, shit. I was panicking. Don't fuck. Dude, simple math is fucking me. Plus and fucking minus. So it is n minus 1. You cannot trust yourself anymore. You can n minus 1 R minus 1 sigma AI theta I plus T sigma theta I squared. And that turns to a plus. That's it, sigma theta I squared, sigma AI theta I. 1 plus R sigma AI theta I minus, this is minus. And done. And done. Okay. Now you can say, let's go over the here. You say I have my constraints like your objective for yourself, but what I want to add is the constraints is 1 over R squared sigma theta I squared R minus F plus F R minus F sigma F plus F T sigma, which you will minus times minus F minus R minus F. Perfect. S sigma A omega T sigma A theta I minus n minus 1 F minus R. Exactly. Will be actually plus Rn minus 1 minus 1 R. And second one is one over sigma theta I is R squared sigma theta I squared 1 plus R sigma I theta I minus T sigma theta I squared plus n over sigma omega squared sigma AI omega squared S sigma AI omega T sigma AI theta I n minus 1 1 plus r sigma AH. Exactly lambda for the first and second inequality. Exactly. Alright, so let's make it more similar to what we have based on f and stuff here. So first PSD constraint, we want to make it then I can say we want to maximize what do we want to maximize? We want to maximize eta is positive, so I can divide by eta. Um, that's it, what we want to maximize, and our constraints are so compared to optimal welfare, you can see that the coefficient in the objective function sigma AIAJ for sigma AIAJ changes by a factor of 2 minus eta over 2 plus eta, and you can see that that can change actually a lot based on if eta is bigger than 2 or less than 2. We can see that the constraint that is binding can be either first best or second best. Subject to 1 over r squared sigma theta I squared 1 over r squared sigma theta I squared f minus r sigma AI theta I minus ft sigma theta I squared the whole shit squared is sigma AI omega T sigma AI theta I S sigma AI omega theta I minus, yeah, let's skip that. I don't like n minus 1, yeah, I don't like that term actually. So I say plus n minus 1, fuck it, keep things simple. Alright, I'm doing what I want to do. Plus n minus 1 r minus 1 sigma. AJ, this is the first PSD, and the second will be one over r squared sigma theta I squared f minus r sigma AI theta I minus ft sigma theta I squared. Oh shit, no. 1 plus r sigma AI theta I minus t sigma theta I squared, the whole thing is squared, plus n over sigma omega squared less than or equal S sigma AI omega plus T sigma AI theta I plus n minus 1 plus r sigma AI AJ. Let me check if it is the same shit. So fucking annoying. Alright, sounds good. And that's it. Then we wanna do what? What we wanna do is find lambda and nu. This is called lambda for this one, nu for this one. So we are gonna, we haven't function eta by the way, right? It seems we don't have eta, so I can use eta. Yeah. We wanna say the objective is less than lambda We keep lambda positive and nu non-negative, nu non-negative, so the direction doesn't change. And we take everything to the left side of inequalities because we want to say objective plus constraints are less than or equal. Yeah, the Lagrangian objective should be greater than our own objective. So we take everything to the right hand side. Yeah. All right. I need to write it here. You can have this maybe. So we have n minus 1r greater than plus lambda s sigma a omega la 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 minus 1 over r squared la 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 plus, well, objective is less than this lambda times that shit plus nu times s sigma a omega minus 1 over r squared. All right, and then we wanna round L round sigma AIAJ round L round sigma AIAJ will be n minus 1 r so round L round sigma AIAJ will be n minus 1 r 2 minus eta 2 plus eta. Actually, it should be the same thing, just 1 2 minus eta 2 plus eta is added, and plus n minus 1 r minus 1, that's it, plus n minus 1 1 plus r. So let's see if you have this formula. So if we remove n minus 1, we have r. Now this is just minus r 2 minus eta over, we are dividing by minus n minus 1, 2 minus eta 2 plus eta plus minus r plus f plus, sorry, minus 1 plus r 0. So minus r of lambda nu minus r 2 minus eta over 2 plus eta plus f minus r lambda minus 1 plus r nu equals 0. Exactly. Minus r 2 minus eta 2 plus eta two plus eta plus plus f minus r lambda minus 1 plus r nu equals 0. Now let's compute sigma ai omega. Yeah, let's do sigma omega. Round L round sigma ai omega equals S plus lambda S plus lambda S plus nu S minus two n nu sigma ai omega over sigma omega squared equals 0. This should not change, right? Minus s lambda plus nu 2n over sigma omega squared sigma a omega minus s should be 0. Perfect. And yeah, let's write it here too. Sigma equals 0. What is it? Tell me. That doesn't change, yeah. Minus s lambda plus nu 2n sigma ai omega over sigma omega squared minus s equals 0. Perfect. Minus s lambda plus nu 2n sigma a omega over sigma minus s equals 0. Perfect. And sigma a theta I, that one may be a bit nasty. Round L round sigma ai theta I equals 0 equals t t plus lambda t minus lambda over r squared sigma theta I squared f minus r sigma ai theta I minus ft sigma theta I squared times f minus r. So, okay, plus nu t minus nu 1 over r squared sigma theta I squared 1 plus r sigma ai theta I minus t sigma theta I squared. This should not change as well, right? This should not change. plus r. That's it, equals 0. So we have t, so we have f minus r sigma ai theta I minus ft sigma ai theta I times f minus r squared sigma theta I squared. Where is the 2? Oh, 2 by the way, yeah, 2 lambda f minus r squared sigma theta I squared plus 2 nu 1 plus r, yeah, sigma I theta I, yeah, over r squared sigma I minus, then minus t minus lambda t minus lambda nu t. Okay, perfect. These are all good. From the first one we can compute. So the only thing that changed is the first one. Only thing that changed is this first one. Two lambda f minus r over r squared sigma theta I squared f minus r sigma ai theta I minus ft sigma theta I squared plus 2 nu plus 2 nu 1 plus r over r squared sigma theta I squared. Uh, 1 plus r sigma ai theta I minus t sigma theta I squared equals t lambda nu plus 1. And that's good, unchanged. Alright, and then we want to solve it for, first we can find nu from the first two. Here we have a change. Actually we have change, yeah, okay. Nu sigma ai omega and sigma ai theta I can be computed easily based on lambda. Everything based on lambda, by the way. Okay, that's nasty. Can I give it to ChatGPT? Actually, that's a really good idea. So the parameters we want is solve it based on lambda and Compute. Calculate, huh? Calculate. R, not R. Nu sigma AI omega and sigma AI theta I. Where is it? That's optimal revenue. R, where is it? R, nu sigma AI omega and sigma AI theta I. Nu sigma I omega and sigma I theta I. Dude, bro. Sigma I theta I. So you're saying nu doesn't change? It's just stupid. Oh, but by the way, you should also do round L, round lambda, and round nu, right? KKT, and we have, what is the other guy? So we have a stationarity conditions, and we have okay, yeah, we need to change this. Minus R but it's good to check if that was the case. Minus R frac 2 minus eta 2 plus eta. Meantime, I'm gonna so it says nu is f minus r lambda minus r over 1 plus r. Is it the same? Yes. sigma omega to n and then f plus 1 and f minus r. Where is it? And once we set eta to 0, we should have the same equations, right? Sigma ai omega doesn't change. Oh. But it's based on nu now. Okay. It seems at the end of the day we cannot get help from ChatGPT. Okay, we have KKT conditions. The stationarity coefficient. Okay. If lambda is positive, it means the first PST is binding. If nu is positive, it means second one is binding. And then we are minimizing on lambda and nu, the nu function. Okay. First things first. Minus r 2 minus eta over 2 plus eta plus f minus r lambda minus 1 plus r nu equals 0. Therefore, nu equals lambda f minus r minus r2 minus eta 2 plus eta over 1 plus r. Is it what ChatGPT says too? F minus r lambda minus r2 minus eta 2 plus eta 1 plus r. Check. Sigma ai omega equals is lambda plus 1 over nu. Should nu be 0? If nu is 0, let's assume nu is not 0. So s lambda plus 1 over nu, the whole shit plus s, and times sigma omega squared over 20, which will be s lambda plus nu plus 1 over nu sigma omega squared 20. Here r is negative, f minus r is positive. So we cannot say if nu is positive or negative. If r is negative, this shit is positive. Based on eta, but we know that nu should be non-negative. If it's giving us nu something negative, if I choose eta very big, nu becomes negative. What? Doesn't make sense. Unless you're saying lambda depends on. This motherfucker should be positive, not negative. If nu is 0, well, if nu gets negative, it means nu is 0, and the second PSD is not necessarily binding. Alright, let's write it down. Nu is lambda f minus r. Actually, f minus r lambda is nicer, as we have it here too, right? No, fuck you. Okay. Lambda f minus r 2 minus eta over 2 plus eta, the whole things over 1 plus r, which should be non-negative, and sigma ai omega equals, here we have it based on only lambda and r. Calculate sigma ai omega based using the calculated value for nu. So meanwhile we will do it as well. I had it here. I agree with this part, that sigma AI omega equals S plus lambda plus nu sigma omega squared over 2n nu. That's true. But if you wanna substitute that, is 1 plus lambda f minus r minus r 2 minus eta 2 plus eta sigma omega squared over 2n nu, which is lambda f minus r 2 minus eta over 1 plus r. I will be nasty. Sigma AI omega will be S one plus lambda r plus 1 plus f minus r minus r 2 minus eta 2 plus eta over 2n f minus r lambda minus r 2 minus eta sigma omega squared. Is it for eta when eta is 0? S sigma omega squared over 2n with the 1 plus lambda 1 plus r plus f minus r over f minus r lambda minus r will be lambda plus r plus lambda r plus 1 f minus 2r. So this is going with this one. Over f lambda f minus r is true. And you say the lambda nf plus 1. So you're saying lambda plus lambda r minus r plus f equals lambda nf. Yeah, it equals, because no, wait. Well, they're not matching. Lambda plus lambda r plus 1 plus f minus r over 2n is already taken, sigma 2n. Lambda f minus r, perfect. And you're saying lambda plus lambda r plus 1 minus r plus f equals lambda nf. Nf, what is nf? N is 1 over f, but there is no r here. That's my problem. Nf is 1 plus f. So you're saying lambda doesn't make sense. Oh, I think ChatGPT fucking dumb. You computed it wrong. What do you mean apologies? Fuck you, dude. Fuck off. This part we agree. Okay. Let's check. F minus r lambda minus r 2 minus eta over 2 plus eta over 1 plus r over 2n. Shit. AI omega equals is that 1 plus lambda plus nu over a sigma omega over 2. That's true, I agree with this term. It's 1 plus lambda plus nu sigma omega 2n and over v. Yes, over v. Nu. And then we are S2n nu. Okay, 1 plus lambda plus nu. Lambda f minus r 2 minus eta 2 plus eta 1 plus r sigma omega squared 2n f minus r lambda minus r 2 minus eta 2 plus eta or r 1 plus r. Simplifying the expression, I multiply both the numerator 1 plus r, unite the fraction within the fraction. It will be lambda 1 plus lambda 1 plus r f minus r lambda minus r 2 minus eta over 2 plus eta sigma omega squared. Well, actually I like that. This term is right. 2n f minus r lambda minus r 2 minus eta over 2. This is good. Let's keep it this. Yeah, actually perfect. Sigma AI omega is S 1 plus lambda r plus 1 f minus r lambda minus r there then omega 2n f minus r lambda minus r there then so this is example, but I think this is true. Yeah, it sounds this is fucking true. I like that it breaks the shit down. So sigma AI omega equals S 1 plus lambda plus nu sigma omega squared. I want to write it down. S sigma omega squared over 2n nu, which equals S sigma omega squared over 2n S sigma omega squared over 2n lambda plus 1 r plus 1 plus f minus r lambda minus r 2 minus eta 2 plus eta and over f minus r lambda minus r 2 minus eta 2 plus eta. Eta is the coefficient behind the consumer's utility, right? Yeah. And then I'm saying if we remove consumer's utility, eta 0, we should have lambda plus 1, r plus 1, plus f minus r minus r, sorry, lambda minus r over f minus r lambda minus r. This should be equal to lambda nf plus 1 over 2n, sorry, lambda f minus r minus. The lambda f minus r, it goes away. Saying these two should be equal. So it will be lambda r plus lambda r plus lambda plus r plus 1 plus lambda f minus r minus r should be equal to lambda nf is 1 plus f. 1 lambda plus lambda f plus 1. So is it true? 1 goes away. Lambda goes away. R goes away. Lambda f goes away. Okay, so I was just, it's okay. ChatGPT is always right. I am the one who cannot do simple mathematics. All right, and I'm proud that I cannot do fucking simple, stupid mathematics. All right. Perfect, which results in this term, and let's compute for sigma ai theta I, which comes from the third one. Sigma ai theta I equals. Can you compute based on so let's look at our code. Maybe we can write this sigma I theta I based on this, and it's far easier. We have nu, we have lambda. Oh, we don't have lambda. So how is our code? It takes the lambda, it doesn't take the nu, and r. You can add a simple nu here. That's not a big deal. Yeah, let's do that. Let's make it much easier. And then let's assume we have these three. Let's also check the calculation for sigma I theta I. Two lambda, is it the equation we have? 2 lambda f minus r squared sigma theta I squared f minus r sigma I theta I minus ft sigma theta I squared plus 2 nu 1 plus r over r squared sigma theta I squared 1 plus r sigma I theta I minus t sigma theta I squared equals t lambda nu plus 1. That sounds right. Common terms. What is the common term? Same thing. I don't see any difference yet. We just put the 2 lambda and put 2 nu on the top. Numerator, expand the terms. 2 lambda f minus r squared sigma theta I squared sigma I theta I minus 2 lambda f minus r ft over r squared plus 2 nu 1 plus r squared sigma I theta I r squared greater than minus 2 nu 1 plus r squared. What about the t? Where is the t? Oh, t, okay, 2 nu t, alright. 2 nu t, 2 lambda ft, perfect. T greater than, combine like terms, sigma I theta I, 2 lambda f minus r squared over plus 2 nu 1 plus r squared over r squared sigma theta I squared equals t lambda plus nu plus 1 plus 2 lambda ft f minus r squared plus 2 nu t 1 plus r squared God save ChatGPT. God bless America. Alright, sigma AI theta I will be 2 lambda f minus r squared plus 2 nu 1 plus r squared sigma theta I squared t lambda la 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 plus 2 lambda f t f minus r plus 2 nu t 1 plus r over r squared. Simplifying further means trimming by r squared and factoring out the t r squared sigma theta I squared. Alright, t lambda plus v plus nu plus 1 r squared 2 lambda f minus r 2 nu 1 plus r sigma theta I squared 2 lambda f minus r squared plus 2 nu 1 plus r squared. Perfect. Final solution. I like this solution actually. And then we wanna and we wanna say, okay, everything now is based on lambda and r. R is not a parameter. Lambda is the parameter. Lambda. Alright. Now I wanna tell you guys. Now we have everything. How much time? I'm gonna finish this. I'm not gonna. What is lambda? Lambda should be non-negative, by the way. Nu should be non-negative, by the way, as well. So, fuck me. Lambda, let's assume nu will be non-negative. At the end we change it, we check it. I mean, lambda. What is the equation that gives us the lambda? Let's look at the main optimization problem. If nu is positive, we can find sigma AI theta I. If nu is 0, first one is not. Okay, by the way, we know what's going on here. If eta we know which constraint is binding based on value of theta. R is negative. Okay, R is negative. N minus 1 R minus 1 is negative. Let's assume eta is less than 2, greater than or equal 0. Then this term in objective function, coefficient of sigma AI Aj will be negative. R is negative. So we want to maximize it, we want to minimize sigma AI Aj, and for that we need a lower band for sigma AI Aj, which second one is binding. And if eta is greater than eta is greater than 2, the in objective sigma Aj is positive. The coefficient for sigma Aj is positive. In order to maximize it, we want to have sigma Aj as big as possible, and we want to find something that gives us an upper bound on sigma ai aj. The second one does not give us an upper bound. The first one looks like a lower bound, but r is negative, n minus 1, r minus 1 is negative, so it is giving us first PSD binds. And what if eta is 2? Well, at this situation, wait, eta is 2, what is going on? We have no care on sigma iaj, and we have no lower bound. No, we have it on sigma. We have bounds on sigma ai theta I plus a sigma ai omega. They don't look like lower bound, but because the left hand side is sigma ai theta I and sigma ai omega, we cannot say shit yet. And eta equals 2. So right, sigma ai omega, sigma ai theta I, and sigma ai aj on this page are free variables as long as they satisfies these two inequalities, right? If I have a triple of sigma iaj, sigma ai omega, sigma ai theta I that is working, and let's assume eta is less than 2, then I can eta is less than 2, I can decrease my sigma iaj. Alright, my first constraint won't be violated, my second one may violate, so I make sure the second one binds. The same with eta greater than 2. If I have actually eta okay, if eta is greater than 2, I want my sigma iaj be as big as possible. If you give me a triple of sigma iaj, sigma ai omega, and sigma ai theta I, by keeping the sigma ai theta I and sigma ai omega, but adding sigma iaj, my second one keeps, my second PSD constraint won't be violated, but my first PSD constraints, the right hand side starts to decrease and will be violated, right? Therefore, eta greater than 2 first best will bind. Now, when eta is 2, objective doesn't depend on sigma iaj. But can I increase or decrease sigma iaj as much as I want? What I care is S sigma I omega plus T sigma I theta I. I cannot change them freely. For example, I cannot add sigma I theta I to very big numbers because we know that left hand side is increasing quadratically while right hand side of the first PSD constraint is increasing linearly. So there is a point that left hand side gets bigger, right? So let's assume S sigma I omega, sigma I theta I works. We cannot increase them what is it called? Arbitrarily because of the quadratic term on the left hand side. However, if I have a triple that works, I still have some room for sigma iaj. In the first PSD, it has a negative coefficient. So by increasing it, I can make first PSD bind, or by decreasing it I can make the second PSD bind. It's just, but it doesn't change the objective. So I have actually a range for sigma IAJ. We are moving over a link here, and all of those solutions works. We can have multiple options. Sigma AIAJ can move on the interval. Perfect. And so let's say eta is less than 2. Second one binds. And second one binds means that lambda should be positive. And nu should be 0. Alright. Yeah, that's a good idea to go with. Eta less than 2, greater than 0. What did I say? Eta greater than 0, less than 2. Fucking second binds, which is lambda positive, and nu should be 0. Should be 0. Okay, we have lambda I, fi should be non-negative. So if lambda is positive, then lambda should be non-negative. If lambda is positive, we can say that the constraints bind. But if lambda is it? Let's take a look at the convex optimization. Books, where are my books? Nope, where is it? Research, yeah, convex optimization. Duality. Optimality condition. Complementary slackness. So we want lambda I fi should be 0. Oh, that's great. Now if lambda I is positive, then fi should be, but if lambda I is 0, fi can be non-negative. Alright, each term should be 0. Complementary slackness, it holds for inf. Or fi is 0. Or fi if fi is negative. So if we get a negative nu, what it means is that we cannot have negative nu. The other one should bind. But I mean, negative is not good. It should be non-negative. So lambda I fi should be 0. If nu is not 0, its constraint should be 0. Gradient should be 0. We did it. Yeah. That's it. I cannot say more. Alright guys, we take a break, we come back.